Hey students, it's Mrs. Decker, and today we are going to start our first process of working backwards. So our first lesson here on factoring is we're going to be looking for a greatest common factor and factoring that out of the expression. But before we get into the notes here, I just want to kind of take a look at an example and definitely want to make sure that you have some paper so that you can jot down these examples and have that resource as you work on the Khan Academy assignment for today. But I want to look at us going forward first. So let's say I have a monomial, so just one term, 2x, and I'm multiplying that by a binomial, x minus 5. So we see those parentheses, we think distributive property, and that's exactly what we're going to do moving forward. So if I multiply the 2x by everything inside the parentheses, I'm going to get 2x squared, and then 2x times negative 5 will be negative 10x. Okay, so that's going forward. So today what we're going to be doing is we're going to be starting with the 2x squared minus 10x. And we're going to be reversing that process of distributing, and we're going to factor. Okay, and so our final answers would be 2x times x minus 5 if we were starting with the 2x squared minus 10x. So we're basically just undoing the distributive property. Okay, we call that factoring. Undoing the distributive property is called factoring. Okay, and you guys have heard of factors for a long time now. Back in elementary or maybe late elementary, middle school, you had to list the factors of a number. So first question here says, what are the factors of 12? So I have to think of all the ways I can multiply to get 12. So I like to do a little tree diagram thingy. So I can always do 1 times itself. I can do 2 times 6. And I could do 4 times 3. And I ran out of room, so let me try to... Maybe I'm not going to do the tree diagram because there's not enough room. So sometimes you did like in a list, kind of like this, or you had the biggest at the end and the smallest at the beginning. So 1 times 12, and then 2 times 6, and then 3 times 4. So those are all the factors of 12. We can do the same thing for 18 here. So 18, I can always do 1 times 18. I can do 2 times 9. And I can do 3 times 6 to get 18. So both 12 and 18 have quite a bit of factors. And so we want to find the greatest factor that they share that's in common. So that looks like it's going to be 6. They both have 6 in common. They both also have 2 and 3 in common, but 6 is the greatest. So the GCF, greatest common factor, of 12 and 18 is 6. So that's going to be the first part when you're factoring, is to look at all the pieces in that expression and look for a greatest common factor between all of those pieces. So if I look at number 1, I'm focusing on 5x and 25. And I'm asking myself, what do they have in common? Or what can I divide both by? And so this one should really stand out to you, right? You can divide by 5. Okay, so the GCF, the greatest common factor, is 5. Now, looking at the second example, if we think of just the coefficients, the numbers out front, 1 and 2, they don't share a greatest common factor other than 1. We could divide both by 1, but 1 doesn't count because it doesn't change anything. So you also want to look at the variables. So in the first term, x to the 4th, well, that just means x times x times x times x. And x squared just means x times x. So if I look at each of these pieces, the x to the fourth piece and the 2x squared, again, I'm looking for something that they share. What do they have in common? Well, both of them have two x's. They both share two factors of x. So I'm going to circle those two x's. And so the GCF is an x squared. I can divide out, or I can pull out x squared from both pieces. Now looking at example number 3 kind of merges together examples 1 and 2. So focusing on both pieces here, we have the 4x to the 5th and the 2x to the 3rd. The first thing I want to look at is the 4 and the 2, the coefficients, the big numbers in front. Well, 4 and 2, I can divide both of those by 2. And then looking at the powers, I have 5 x's in the first term and 3 x's in the second term. So they both share at least 3 x's, or x to the 3rd. Okay, so sometimes students have a hard time with the variable because they think greatest, so they want to pull the biggest power out, but it's actually the opposite with the variables. You want to pull the smallest out because they have to share them both. They have to both have that many. So you can't take 5 x's out of the 3 x's. Okay, you can only take 3 out of both. And then the last example here, again, breaking it into those two parts of just looking at the coefficients, the numbers in front. So 1, 2, and 5. Do 1, 2, and 5 share any factors, or could I divide 1, 2, and 5 by some number? You can't, right? You can only divide by 1. So we move on to the variables. And so I have 4 x's in the first term, 2 x's in the second term, and 1 x in the third. So they all have at least 1 x. So my GCF is just x. Okay. So that's going to be your first part, is just identifying what you can take out of each term or each piece. Okay. And we kind of talked about this idea already, but when you factor, you are just doing the reverse distributive property. Okay, so you can always check your answer by redistributing and making sure that you get back to what you started with. And so there's an example here that how to show you that the two expressions are equivalent. They're the same thing. They mean the same thing. They're just written two different ways. So if I look at the one on the right side of the equal sign, if I redistribute that, 2x times x is 2x to the second, and 2x times 3 is 6x, okay, I get right back to what I started with. Okay, so you're just rewriting the expression. So let's look at some more examples here. I have some steps here. So first, determine the greatest common factor. Okay, and that greatest common factor is going to be the monomial that's in front of the parentheses. And then you're going to divide out that greatest common factor, and what is left, that's going to go inside the parentheses. Okay, and then you can check by redistributing. So your answer, you're going to have your GCF in front, and then in parentheses is what's going to be left over after you divide. Okay, so your answer is going to always have this form. GCF out front, what you get after you divide inside the parentheses. So first example here, 3x plus 12. I'm asking myself, what can I divide from both terms? So I can divide out a 3. That's my GCF. And so I'm going to pull that 3 out front. And what's going to be left is going to go inside my parentheses. So 3x divided by 3, well, the 3's just cancel. I'm left with x. And then 12 divided by 3 is a positive 4. And doing a quick check to make sure I get back. If I redistribute, I get 3x. And 3 times 4 is 12. So I got back to what I started with. Second example is very similar, but notice the powers have increased. So I now have an x squared and the 12 has an x. So this just means they also share an x in common. So I can take out a 3x out of each piece. So what I take out is going to go in front of my answer. And then what's left over is going to go inside the parentheses. So from the first piece, the 3's cancel, and I started with x to the second, but I'm taking an x out, so I'm only going to have one x left. And the second term, 12 divided by 3, well, we know that's 4. And then I'm taking an x out, so the x's cancel out. Okay, again, recheck. 3x times x is 3x squared, and 3x times 4 is 12x. Okay, third example, we have 3x plus 18x to the third. Again, let's see, what can I divide by? So each piece I can divide by a 3. And then thinking about the variable, they both terms, both pieces share 1x. So I'm going to take out a 3x. Okay, so what I'm dividing by, that's part of my answer. That 3x, it has to be in my answer. It's the thing that I distribute. Now, something unique happens here. When I take that 3x out of the first term, notice everything cancels. Okay, but remember, you have to distribute that to something to get back to 3x. Okay, and so anything divided by itself is just 1. So you do need a placeholder there. It's going to be a 1. And then moving on to the next term, 18 divided by 3 is 6. And I started with x to the third, but I'm taking out an x. So I'll have 1 less. So x to the second. Okay. Number 4, now we move on to a trinomial. So we have 3 terms, so all 3 terms have to share a common factor. So first start with the numbers out front, 5, 20, and 15. I can divide all those by 5. And now thinking about the variable, do they all share an x? Well, the 15 doesn't have an x, so I can't take an x out of it. If I can't take an x out of everything, I can't take an x out of anything. Okay, so the only thing I'm dividing out is the 5. That's my GCF. And what's left over from the first term, 5's cancel, so just x squared. 20 divided by 5 is 4. X tags along. And then negative 15 divided by 5 is negative 3. And so my answer, kitty cat was on my Chromebook. There we go. Okay, looking at number 5, back to just 2 terms, 24 and 16. So definitely even numbers. I can divide by 2, but can I divide by a bigger number? Can I divide by 3? No, not 16. 4 looks good. 4 divided by 24 is 6. And 16 divided by 4 is 4, but though it still has a factor left, so there's got to be a bigger one. How about 8? Yeah, I can divide both of those by 8. So remember, you want to pick that largest number that you can divide out. So I'm going to pull out an 8, and what's left over, 24 divided by 8 is 3. X squared's just going to tag along because I didn't have an x on the 16 to take out. And then 16 divided by 8 is 2. Okay. And so make sure that what's left inside the parentheses, there's no common factor inside the parentheses because you should have pulled everything out front the first time. So if you do see, oh, I can still divide inside the parentheses, then that's a red flag to, hey, go back and pick a bigger number to divide by. Number 6 is a unique case because 3 and 10 do not share a common factor, and they both don't have a variable. So there is no GCF here, and that can happen. Some things you can't factor. Some things are prime, right? Some numbers are prime. So when that happens, you can just write prime or not factorable. Okay, so that will happen. So be aware of that. And if you can't find a GCF, it doesn't necessarily mean that you're doing it wrong. It just may not be able to be factored. Okay. All right, we got 4 more to go. Number 7, x to the 7th plus 4x to the 3rd. If I look at the numbers out front, 1 and 4 do not share a common factor, so I move on to the variables, x to the 7th and x to the 3rd. How many do they share? How many do they both have? Well, they both have at least 3 x's. Right, I can take out 3 x's from the 7, and I can take them all out of the second term. So remember that GCF has got to go out front, and what's left? In my first term, I started with 7 x's, taking out 3, so I only have 4 left. And second term, I'm taking them all out, so they cancel. I'm just left with 4, the big 4. Again, remember you guys can redistribute. So x to the 3rd times x to the 4th is x to the 7th. And that is 4x cubed. So we get back to what we started with. Okay, number 8. We got 3x to the 3rd minus 9x squared plus 15x. Thinking about the numbers first, 3, 9, and 15. I can take out 3 out of all of those. And can I take a variable out? Well, the 15 doesn't have it. So I'm just going to divide out a 3. And what's left over? X cubed minus 3x squared plus 5. All right, so those variables just tag along. If you're not taking any variables out, they just stay the same. Number 9 looks like we can divide everything by 2, and they all share an x. So let's take out a 2x. 2x goes out front. That's what I'm going to distribute through. What's left? Oh, the 2's cancel on the first term. Started with x to the 3rd, but I'm taking an x out, so only have 2 left. 16 divided by 2 is 8, and I'll have 1x left there. And then 8 divided by 2 is 4, and my x's cancel. Okay, so we'll have 2x times x squared plus 8x plus 4. And then last but not least, the final example, we have 15x cubed plus 4, looking at 15 and 4, and asking myself, do they share a common factor? Is there something I can divide both 15 and 4 by? And the answer is no. Then I move on to the variables. Do they both share x's? Do they both have x's? And no, they do not. So if I can't divide out anything, then it is prime. I can't factor it. All right, so that was our first lesson on factoring by factoring out a common factor between all of the terms. I want to kind of break that into 2 parts. Look at the coefficients, the big numbers out front. Look for a common factor between those, and then think about the variable. Remember, you want to pull out the least variable that they all share. Okay. As always, please email me with any questions or concerns that you have as you go throughout the practice problems or if anything comes up. And I hope you guys have a good day.